Hey everybody, this is left hydraulic bay of A320, and here we have rammer turbine, and today I will show you how to test it and tell you a little bit about it, so stay tuned. First of all, let's take a look on rad test flow control kit and what kind of information it can give you. On the first display you can see how many liters flow through the tester per minute, and you can adjust it through the flow control valve. On second display you can see RPM of the rad, and on the third how much pressure it produces. On this gauge you can see temperature of hydraulic fluid, and on the next one is a pressure of hydraulic in the system. In the socket inside we can find the hydraulic motor, which will connect to the rammer turbine, and we will simulate airflow with it, but I will show you how it works a little bit later. As a first thing, I need to pull CB in the left EE compartment. Next step is deployment of the rad, and we need to do it twice. One button is on the hydraulic panel and the second one is on the electric panel, but I will show you just one attempt because for the second round I was outside. Next step is pulling one CB behind the first officer. First two tests successfully passed, so now we can proceed with the installation of all equipment which we'll need for the remaining test. As a first, we'll install hydraulic motor, which I mentioned before. And for that we need to remove cover plate from the backside of the rammer turbine. When cover is removed, you can see the hole inside of the rammer turbine gearbox. Inside of that one will fit the drive shaft from the hydraulic motor. Let me tell you a little bit about the rammer turbine. The turbine is constant speed variable pitch unit with the two blades. The mechanical governor and the pitch changer mechanism are installed inside of the hub. The turbine is attached to the lower end of the leg assembly and operates the gearbox which drives the hydraulic pump. The hydraulic pump has a stall protection, about which I will tell you a little bit later. Now, what's the purpose of the rad? In emergency, the hydraulic pump of the rad supplies blue hydraulic system. Electrical power can be also supplied through the blue auxiliary system by the constant speed motor generator. The really interesting fact is that the system supplies hydraulic power in less than 4.5 seconds from the time it gets electrical command to extend. An automatic function only operates when the speed of the aircraft is more than 100 knots. Hydraulic power available from the rad is sufficient to supply flight controls and the generator. This was just a brief description how rad works, but if you want to know more, take a look on the video made by Stick Aviation, where he gives you much more information, and actually this is part of that video. I will leave the link in the description below, so go and take a look after you watch this one. And let's go back to the test. Safety is always priority, so as the next step is installation of the protection cage. Cage is on place, so we can proceed with installation of the flow controller. It must be connected to the pressure and return line of the blue hydraulic ground connection. This way we'll have a direct access to the pressure, which will be produced by rammer turbine during test. Return hose is on the place, now we're gonna fight with the pressure hose. All what's remaining is to connect test kit to the aircraft so we can receive all information about rammer turbine performance. Here comes the last piece of equipment which we're gonna need for this test. This is our hydraulic power unit, which we're gonna use for supplying of the hydraulic motor, which will fit on the back side of the rammer turbine. We are using it for various tests, like a gear swing or this rammer turbine test. Of course, you can use it also for draining or filling of the hydraulic system. Now, what is the purpose of the motor? On the ground we don't have an airflow which is necessary for rotating of the ram air turbine, so we need to simulate it somehow, and for that purpose we have here hydraulic power unit and hydraulic motor. With pressure 3000 psi provided by hydraulic power unit, ram air turbine is supposed to have nominal speed around 5000 revolution per minute. And that's why we're doing this test to confirm it, but of course we will test other things as well. Well, every part of the hardware is installed, we are ready for the test. First part of the test is performed on the cockpit. My colleague will switch on the blue leak measurement off and he will pressurize blue hydraulic system by electric pump. This way we will know that check valve is not blocked in open position, and it means the ram air turbine will not turn. Whenever this is confirmed, we will pressurize hydraulic cart which will initiate rotation of the ram air turbine. When pressure and RPM of the ram air turbine are stabilized, I'll give signal to my colleague to switch off blue hydraulic pump, and from now on we'll continue only from the ground. Nominal speed of the ram air turbine is okay, so now I'll adjust the flow to 30 liters per minute. This way I'll create demand in the hydraulic system, and the ram air turbine must be able to handle the load, and it must keep stable pressure and RPM above the limit. And all values are okay, so I'll set the flow control back to 0. For the next step, my colleague needs to reduce the pressure on the hydraulic cart, and this way we're going to simulate a lower speed of the aircraft. When we have stable pressure on hydraulic cart, I'll adjust the flow to 60 liters per minute. In this condition, will rad pump operate in anti-stall condition. And what does it mean? Anti-stall valve, which is inside of the ram air turbine, will reduce outgoing flow, which will remove the load from the hydraulic pump of ram air turbine. And this way, rad can hold the RPM. If we will have a fault on anti-stall valve, we can observe it on the test kit by dropping in pressure or revolution. We need to be quite fast with the test because temperature of the hydraulic fluid must not exceed 60 degrees of Celsius. As you can see, we are both happy with values, and I'll reduce the flow back to 0 liters per minute. This is the last check of the parameters, and since all of them are okay, that passed the test. As you can see, test was fast. And now we need to remove all equipment and return aircraft back to serviceable condition. The hydraulic cart was already removed, now I'm removing protection cage, and lately I'll take care of the hydraulic motor. And meanwhile I'm removing hydraulic motor, my colleague is packing flow control test kit. All what's remaining is installation of the cover plate and retraction of the ram air turbine. For retraction of the ram air turbine, you must set it to exact position. If you leave it in any other position and you will try to retract it, the rad will not move and you will receive fault light on the control panel. This is a safety feature against the damage. Rod has been retracted and all what's remaining is to close 2 CBs. That's all what I want to show you about the Rammer turbine test. If you want to know more about this device, take a look on the Stick Aviation video as I mentioned before. Link will be in the description below. If you have any questions, write them down in the comments below and I will try to answer you as soon as possible. Big thanks to all of my colleagues which was around, because as you can see it is always about teamwork. If you want to see more aviation content from my side, take a look on one of these 2 videos. My name is Tomáš, this was Aircraft Maintenance with Zetor, and I will see you on the next one. Bye.